Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal of chemistry and I am dealing with thermodynamics. In this topic, this is lecture number 29 and in this lecture I am going to discuss the Carnot cycle once again. I have already taken 2 lectures on Carnot cycle. Now in previous lecture I explained you step 1 and step 2 of Carnot cycle. Now in this lecture I will explain you step 3, and step 3 is isothermal compression. How it takes place, let us see this. So first of all, we'll draw a cylinder and it was at V3 volume. So piston was somewhere here, which is I think the highest volume ever in this process, and now it is kept on a sink. Okay, then what happened? Let us see this. Because the temperature of the sink is lower, and therefore temperature changes and therefore volume also changes, and piston will move down somewhere here. Okay, so the condition is this one, that here the volume is V3 and it is sink Y in which we have kept it, and temperature of sink is T2 and temperature of cylinder is T1, I think. T2 only. So volume is V3, the pressure will be P3. Okay. From this, if heat is coming out from vessel and it goes to the sink because temperature of the sink is lower and therefore pressure decreased and volume also decreases and it goes to V4 and temperature is T2. Here this is a sink, and as heat is coming out of this vessel cylinder and therefore it is energy transfer from cylinder to sink, so it is called exothermic reaction, and as compression of the gas takes place we call it isothermal compression because temperature remain constant. So it is isothermal compression at T2 temperature, and here volume decreases, pressure decreases, and the volume decreases from V3 to V4. Pressure decreases, pressure from P3 to P4 I think slightly increases. So P4 is greater than this, therefore pressure increases, and that is from P3 to P4 pressure increases because volume decreases, and temperature remain constant. There is no change in the temperature, and here energy transfer from cylinder to sink Y, and that is exothermic reaction. So this is exothermic reaction. Okay, so here again we'll write all these things, that when the cylinder is removed from the insulator stand, Z and is placed in contact with sink Y of temperature T2, then the piston is moved downward so as to compress the gas reversibly and isothermally, because temperature remains constant, so it is isothermally from volume V3 to V4. So volume decreases. Okay. So the heat Q2 is rejected to the sink Y. It is exothermic reaction process, and therefore Q will be negative, as the work done on the system W3 will be positive. So here we write minus Q2 is equal to W3 is equal to 2.303 RT2 log V4 upon V3. Okay, so this way we have this equation to find out work in the third process. Now next step, fourth step will be this one, step 4. Here the cylinder was again from sink was taken and kept on an insulator stand, so that volume from V4, which was here, will change. So the final condition will be this one, where volume still decreases and will reach to the original state V1. Because it is on insulator stand Z, this is volume V4, temperature is T2, and this is stand Z, which is insulator, and pressure was P4. Now from this condition it goes to original condition. First initial condition was V1 and pressure is P1. Temperature is T1. Temperature changes, remember this. But heat exchange is not possible because stand Z is insulated stand, and therefore it is called adiabatic compression. Because volume decreases, we consider this as adiabatic compression. As temperature changes but heat does not exchange, so we consider this as adiabatic compression, and temperature increases from T2 to T1. So temperature increased, so that means it is heating, and volume decreases from V4 to V1. So volume decreases, temperature increases, okay, and pressure also increases. So pressure will go from P4 to P1. So pressure increases, volume decreases, temperature increases. So this is adiabatic compression. Okay. Now we'll write something. Now the cylinder is removed and it is kept on stand Z, which is insulated. The piston is allowed to move still downward so as to compress the gas reversibly and adiabatically till the gas acquire temperature T1 and volume V1, that is initial state. So this way it completes the cycle. So here, as it is adiabatic process, heat changes is not possible. Okay, so Q will be 0. So here the work done on the system, therefore W will be positive, and so here W4 is equal to internal energy change delta E is equal to CV into T1 minus T2. Okay, so this is the equation to find out work done in step 4. Okay, now we have to see all these states or all these steps in graphical form. So let us draw a graph. Sorry. This graph is pressure versus volume. Okay. So initially we are here where the pressure is P1 and volume is V1. So this is the original state where pressure is P1 and volume is V1. Okay, so we consider this as initial state, step 1. I think this we have not enough time to finish the graph, so I'll take this graph in next lecture. Thank you so much.